Welcome to Manifested Publishers.
Hello learners, my name is Stephen Kariungi. Today we continue with our topic of discussion, and the topic is acids, bases and salts. So today we are going to discuss the effect of adding sodium hydroxide or potassium hydroxide to salt solutions. So effect of sodium hydroxide or potassium hydroxide solution on salt solutions. So we're going to see what happens when various salt solutions are added to sodium hydroxide or to potassium hydroxide. And this forms the basis of identification of cations using sodium hydroxide. So we'll take an example, or we'll take some examples that when a few drops of sodium hydroxide solution are added to zinc sulfate, a white precipitate is formed. A white precipitate is formed, and you can say that the same occurs when sodium hydroxide is added to magnesium chloride, lead 2 nitrate, aluminium chloride, and barium nitrate solutions. So basically what we are saying is that when you add a few drops of sodium hydroxide solution to zinc sulfate solution, or to aqueous zinc sulfate, a white precipitate is formed. And that white precipitate will be as a result of the exchange of ions between zinc sulfate and sodium hydroxide, so that sodium takes the sulfate to form sodium sulfate, and the zinc takes hydroxide to form zinc hydroxide. So in this case, zinc hydroxide is the white precipitate because it is the one that is insoluble. The same case applies when sodium hydroxide is added to magnesium chloride, lead 2 nitrate, aluminium chloride, and barium nitrate solutions. So that is because sodium hydroxide introduces hydroxide ions to magnesium to form magnesium hydroxide, to lead ions to form lead 2 hydroxide, to form aluminium hydroxide, and to form barium hydroxide, which are white precipitates. That's why the behavior in all this is the same. So we'll take an example. We'll show these in form of equations. So we are saying that sodium hydroxide is added to zinc sulfate So we get sodium sulfate and zinc hydroxide. plus sodium sulfate, which is a solution. So balancing the sodium. So the zinc hydroxide is white PPT. So basically what is happening there, ionically, zinc ions, so we have 2 hydroxide ions from the sodium hydroxide combined with the zinc ions to form zinc hydroxide, the white precipitate. So the same happens with magnesium chloride. That is, you add sodium hydroxide. So we are adding sodium hydroxide solution to all of them to get a white precipitate. So here is magnesium hydroxide, which is the white precipitate, plus sodium chloride. Balance the equation. So this is a white PPT as well. Ionically, magnesium ions plus hydroxide ions from sodium hydroxide, we form magnesium hydroxide, which is the precipitate. Still on the same, we take lead 2 nitrate, is a solution. You add sodium hydroxide again to all of them. So we are forming sodium nitrate and lead 2 hydroxide. Plus sodium nitrate. Balance the nitrates and the sodium. So ionically, that is the ionic equation, we have lead ions. So the ionic equation is only those that are forming the precipitate. That is the lead ions and the hydroxide ions. To form lead 2 hydroxide. And we also have aluminum chloride. Solution. We add sodium hydroxide. We are adding sodium hydroxide to them all. And we are getting a white precipitate in all. So this is still a white precipitate. So here we'll have aluminum hydroxide, which is a solid, plus sodium chloride. Aqueous, 3, we balance 3 there, sodium, and then ionically, aluminum ions plus 3 hydroxide ions. We have aluminum hydroxide, which is still a white precipitate. All these we are forming white precipitates. And make sure that it's balanced. And then lastly, barium nitrate. So number E, barium nitrate. Again, we add sodium hydroxide solution. We'll get barium hydroxide, which is a solid, and then sodium nitrate is the solution. We balance the sodium ionically. These are the barium ions. Ions must have a charge all the time when you are writing the ionic equation. Barium ions are positively charged, 2 positive. Hydroxide ions, there are 2. They are negatively charged. And when they combine, they form barium hydroxide, which is again a white precipitate. So all those equations that we have seen, they are forming a precipitate. And in this case, they are forming a white precipitate. So basically what we can conclude is that sodium hydroxide in all these reactions can be used to identify the ions that are present. So we can say that a point to note is that from the reactions above, sodium hydroxide can be used to identify the cations present. Cations are positive ions present in a salt solution. The cations present in a salt solution. For example, or we can say e.g. zinc ions, barium ions, aluminium ions, lead 2 ions, and magnesium ions all form white precipitates or are forming white precipitates with sodium hydroxide. All of them are forming white precipitates with sodium hydroxide. So that means that they can be identified using sodium hydroxide. So zinc ions, barium ions, aluminium ions, lead 2 ions all form white precipitates with sodium hydroxide. So we'll have an assignment on this. So we have the cations after adding few drops of sodium hydroxide, the color of the precipitate, and the name of the precipitate. We have zinc ions, aluminium ions, calcium ions, and iron 2 ions, and then finally iron 3 ions. So that is the assignment. Complete the table We have the cations column, zinc, aluminium, calcium, ion 2 and ion 3. After you add a few drops of sodium hydroxide to each one of them, what is the color of the precipitate in each and the name of the precipitate. So we'll stop there until next time. Goodbye.